for conditional probability. Okay, so we start with this diagram. What does probability of A mean? From the Venn diagram means we're going to use the highlighter. So everything in here, and out of everything in here, find how many of these are in A. Oops, close it. Find out how many of this is in A. Right, close your laptop please. Yeah. Okay, so that means the probability of A are represented by number of elements in A, right, over how many elements in the sample space. Alright, so how many of the blue one are inside the yellow one? This one, like that. Alright, that's the definition of probability of A in terms of the Venn diagram. And then we have to look at conditional probability, and that's the symbol for conditional probability. It means that if you see a line there, vertical line, that means the probability of event A given B has happened. The probability of A given B has happened. So what does that mean? Okay, so what that means is, given B has happened means that you only have to look at the elements in B, right? And out of this, so you write probability, and then we'll go back to this. So probability of A given B is equal to how many in B, right? So that's the yellow bit, how many in B. And the numerator is out of the ones in B, how many of these are in A, which is how many of these in A, so in this section, right? And this is just the intersection of A and B, like that. All right, good. So what we do is, so this is the formula, so which is written here. The probability of A given B means number of elements in both A and B divided by how many elements in B. Yep, any question? Now you can actually change this in terms of probability as well, which become probability A and B over probability B. Okay, why could we do that? Because we can just divide the numerator and the denominator by the size of the sample space. If you divide the numbers, it becomes the probability. Okay, like that. And then you can have the same formula for probability of B given A. So you just have to reverse A and B. So it will be equal to N, B, and A over probability of A. So the denominator, actually not probability, A, number of elements in A. Like that. That look like an N. Should be N. Okay, good. Or you can write it in terms of probability. Probability B given A is probability of B and A over probability of B. Okay. And then we'll do some examples on that. So this is the formal notation for conditional probability. We did that last year, but now we have to write it in terms of this conditional probability notation. Right. And then we're going to do some examples. So we'll do a simple example about tennis and soccer. All right, all finished. Okay. All right, let's look at this example. Okay. Example 1. So a group of 9 people, 5 like tennis, 6 like soccer, 2 like both. So it's all written on the Venn diagram. I think A represents tennis. So that's tennis. Let's write it on the top so you won't get confused. This is soccer. All right, so it's written on the top. Okay. So find the following probability. So how many elements in A? So A will be 5 out of 9 people. Alright, 5 out of 9. Okay. How about the next one? A and B. You do how many in A and B will be 2 out of 9 people. Okay. Now let's do the conditional probability. We're going to do it in 2 ways. Using the common sense way, how many elements find the probability of A given B has happened. So given that person plays soccer, what's the chance he also play tennis? So that's the meaning of that. What's the chance that given that person plays soccer, because we already know this person plays soccer, there's only 6 out of 6, right? There's only 6 people who play soccer. And out of the 6, there's 2 that plays tennis as well. Right? So this is play soccer. And then this is also play tennis, given play soccer. Okay, so that means 1/3. Okay. Now what if I use this formula I just showed you? You can do the same thing. You can also use this formula. So, or I could show you how this formula works. The probability of A given B is equal to probability of A and B over probability of A. So in that case, you have to divide, actually over given B, over B. Okay. So what you do is you just go A and B is 2 over 9, 2 out of 9. And probability of soccer is 6 out of 9, right? So you just get 2 out of 6, isn't it? Because the 9 get cancelled. So the 9 get cancelled, you only get 2 out of 6, which is 1/3. So which is a long way of doing. So this formula works as well, okay? But it's recommended that you just do it in the simple way. Just ask yourself, how many people play soccer? Out of these who play soccer, how many people play tennis? Okay? All right, good. And then you try the next one. Next one is given that person plays tennis, what's his chance of playing soccer? Okay, so you just say, how many people play tennis? There's 5 play tennis. Out of those who play tennis, only 2 play soccer. Okay? Yep. Mm-hmm. Yeah. 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 Oh, for that one? Yeah, so for that one you get probability A and B over probability A, yes. Yeah, that's for this one, given B. This given B, this is given A. Oh, must be wrong. Oh, oops, sorry, I wrote it on. Thank you. Didn't see that. A given B. All right, good. Thank you. All right, good. Any other questions? Is that what you mean? That's what A given B, right?
No.
That's B given A.
Yeah.
Oh, in different order.
No, I'm saying down the bottom, you did probability of B under the probability of B given and A.
Is it this section here?
Yeah.
Oh, it should be A and B, right? I wrote in different. B. No, it has to be B because given B has happened. That has to be B.
It's meant to be B given A.
Oh! Oh, yeah, I didn't see. Sorry, I was looking at that. Sorry. You're right. Oh, sorry. Okay, B given A. Yeah. Okay. B given A. I looked at the above. I should look at the bottom. So it'll be A. Is that right now?
Yeah.
Okay, sorry. All right, that's right now. Okay. Good. Thank you. All right, all done. We've got one more page. Next page, we have a two-way table. Okay, which we can answer the same question. All right, there's another question, so I'm going to get a student to read. So who want to read? No one? All right, Jaden, go. Yep, thank you. I'm going to represent this information on a two-way table. So the first thing you do is, there's two events, A and B. So A and not A, right? B and not B. And keeping in mind, A means field, and the other one means bench. Right? So put this heading first. Now, from a group of 15 people, so already we know there's 15, so you can write this 15 in the total because there are 15 players. And then they say 7 sat on bench. So already you can put 7 here. That's the number of people who's in the bench. And 13 play on the field, so you write 13 here. So you can fill this information first, the total first, because they gave you the total. And the last information they gave you is 5 play both on the field and bench. And once you fill this in, it's just a matter of subtraction, because once the table is written this way, you can subtract. So you go 7 minus 5 is 2, means 2 play on the bench, not on the field. And 13 minus 5 means 8 is in the field, but not in the bench. And then we shall subtract these 2, you get 2 here. Subtract these 2, you get 8 there. So that means who plays nothing? 0. Once it's finished, we can then do the question. Find the probability that the person only sat on the bench. Yes, Damien. Only at the bench means can only be in the bench, not on the field. Yeah. So basically what they say is in the bench and not in field, right? Which is equal to 2 out of 15. Alright, that's good. How about C? C. Okay, says find the probability that the person sat on the bench. That's a conditional probability, right? Yeah, given he plays on the field, that is sat on the bench. So that means in the denominator, it's going to be how many people who play in the field. There's 13. Right? Out of the 13 people who play in the field, what's the chance he also play on the bench? So 5, right? Is it 5? Yeah, 5 out of 13. Yep. So that's how conditional probability works. Now, again, I didn't use the formula because it just makes it more difficult, isn't it? This is good for theoretical purposes, but for this one, just do it like that. Yes. No, you don't need to use the formula, just use that. But this formula could be useful in some theoretical questions, like some hard challenge questions, where they ask you to find something given the other two polynomial. Okay? Alright, let's look at the next one. Find the probability that person play on the field given they sat on the bench. So A given B. So you can think of A given B is like A over B, isn't it? So you can see the B is in the denominator. So that's a good way to remember. B is in the denominator. Okay, so how many in B? How many people in the bench? 7. So you write 7. Out of the 7 people, how many people play on the field? 5. So 5 out of 7. Yeah. Okay. I think the examples are done. We just need to do one more thing with the formula. That formula actually gives us another formula. So this formula we just seen before, probability of A given B is this. Now, because we learn a lot of algebra, let's get rid of the denominator. How do I get rid of the denominator? What do we do? Both sides by the probability of B. Yeah, so we get a new formula. Let's see what it tells us. So we can use algebra to get a new formula. So this is good for getting another formula. So we end up getting probability of B times probability of A given B equal to probability of A and B. So now we have a formula for two things happening. Probability A and B is probability of B multiplied by probability of A given B has happened. Yeah, we'll have a formula like that. So that's which is written below. Find probability of I don't know. That's yeah. I mean, it can also work it that way, because if I write probability of B given A, that's equal to probability of A and B over probability of A. So that means you can also write probability of A and B equal to probability of A multiplied probability of B given A. So it works in both ways. Alright. That formula you should learn. That will be useful when we calculate the probability of two events happening. That will be useful later on. Okay. Alright, good. So that's probability. So you will try the exercise today on exercise 3D. Okay. Thank you. Yep. Alright.